We are constantly bombarded on the internet with these absolutely mind-blowing, high-definition pictures of distant galaxies scattered all around us in the deep universe. We see galaxies like Andromeda or the Whirlpool Galaxy, beautiful cosmic structures that are millions of light years away from our little blue planet. Yet, despite those impossible, brain-melting distances, we somehow manage to capture crystal clear, colorful images of them. As long as we have massive engineering marvels like the James Webb or Hubble telescopes that can peer deep into the cosmic abyss, it makes perfect sense. We point the lens, we focus, and snap, we get the shot. Up to this point, everything is completely logical and understandable. But here is where things get weird. The real problem pops up when we suddenly see a beautiful, sweeping, panoramic picture of our very own Milky Way galaxy taken entirely from the outside. Wait a minute. Think about that for a second. We live inside the Milky Way. We are buried deep within one of its spiral arms. So, how in the world did we step outside of our own house to take a picture of the roof? Welcome back. I am Night Question. But before we dive into this cosmic mystery, if you are new to the channel, do not forget to subscribe and hit that notification bell so you catch our videos first. See that little red button down there? Be a good friend and smash it for me. Alright, let us break this down with an analogy we can all understand. Imagine this with me. You are standing right in the middle of a massive football stadium. Let's say the Super Bowl is happening and the place is packed. You have your smartphone in your hand and the camera is, well, it is okay, but not great. Suddenly, someone walks up to you and gives you an impossible task. They say, "Hey, I need you to take a clear, full picture of this entire stadium from the outside. I want to see the architecture, the parking lots, the whole thing." What is your immediate reaction? The answer is incredibly simple. You have to leave. You walk out the exit doors, you get in your car, and you drive miles away. Maybe you even rent a helicopter to get some altitude. You put massive distance between yourself and the stadium, turn around, and snap the picture. That is the standard, logical method humans have used for centuries to photograph anything gigantic. You need perspective. But can we apply that exact same logic if we want to take a picture of our own galaxy? Well, to answer that, we need to look at the absolute farthest human-made object ever sent into the void and see if that distance is enough to step out and take a selfie of the Milky Way. Back in 1977, the year Star Wars came out, NASA launched the Voyager 1 space probe. This was a machine built for an epic road trip. It took gorgeous, historic close-ups of Jupiter and Saturn, sent back data that changed science forever, and then it just kept going. It cruised straight through the Kuiper Belt, crossed the magnetic boundary of our solar system, and entered the dark ocean of interstellar space. It is still out there right now, and it will keep drifting until around 2036, when its nuclear battery finally dies. So here is the big question. After all this time, how far did Voyager 1 actually get? After more than 45 years of non-stop travel at hypersonic speeds, it has covered about 3 billion miles. Now, 14.3 billion miles sounds like a terrifyingly huge number. It sounds like enough distance to see something, right? But is it enough to get an outside shot of our galaxy? Consider this context. The Milky Way is, at a minimum estimate, 100,000 light-years across. The distance Voyager 1 has traveled from 1,977 until today equals roughly 21 light-hours. Just hours. That is not even a day trip in cosmic terms. To travel one single light-year, Voyager needs another 18,000 years of travel. We're talking about the year 20,793 just to finish one light-year. And remember, our galaxy is 100,000 of those wide. So, let's be real. It is physically impossible for us to ever step outside our galaxy and snap a picture of it. It's just not happening. Does that mean those beautiful posters on your wall are fake? Is NASA just making things up in Photoshop? Are they pulling a fast one on us? Actually, no. It just means we cannot photograph our galaxy using the traditional method of stepping back. But humans are stubborn, and when we can't do something the easy way, we find a clever way. We found a way to map it from the inside out. Let us go back to that football stadium analogy, but change the rules. What if you were locked inside? We hand you a high-end professional camera and say, photograph the whole stadium, but you are glued to this seat. You would use what we call the mosaic method. You stand perfectly still in the center and start snapping detailed, zoomed-in pictures of every single section around you. A shot of the luxury boxes on the right, a shot of the scoreboard, a shot of the nosebleed seats on the left. You document every inch. Then, you take those hundreds of photos and stitch them together, just like the panorama mode on your iPhone or a giant jigsaw puzzle. Suddenly, you have a massive 360-degree image of the stadium around you. That is exactly, step by step, what astronomers did to map the Milky Way. And this wasn't just NASA's idea. This is a project that has spanned thousands of years of human curiosity. It started with ancient civilizations. People in the desert would look up and notice something bizarre in the night sky during certain months. A glowing milky river of light that split the heavens right down the middle, packed with dense star clusters. They didn't have telescopes, but they had eyes. You can still see this spectacular band today if you go to pitch-black places like Death Valley or the mountains of Utah. One of the most famous early attempts to map this was the Almagest, written by the astronomer Claudius Ptolemy in Alexandria, Egypt. Even though his model of the universe was technically wrong, he thought Earth was the center. His star charts were incredibly precise for the time and served as the reference manual for hundreds of years. Fast forward to 829 AD, Europe was in the Dark Ages. But in Baghdad, the Al-Shamsiyya Observatory was being built during the Islamic Golden Age. Scholars like Al-Biruni, Al-Khwarizmi, and Ibn Sina took astronomy to a new level. They didn't just look, they measured. They discovered massive amounts of stars and grouped them into constellations. In fact, their work was so influential that many stars we study today still carry their original Arabic names, like Deneb, Altair, and Aldebaran. Then came the Renaissance, between the 14th and 17th centuries. This is when European astronomers started measuring star positions with mathematical precision, especially after Galileo revolutionized the telescope. But the first person to really try and draw a shape of the galaxy was the British astronomer William Herschel in 1785. He literally counted stars. He divided the sky into over 600 specific zones and took a census of the stars in each one. When he stitched that data together, he created the Herschel map. It looked like a weird, blobby amoeba, but it was the first real attempt to see our home. A century later, Dutch astronomer Jacobus Kapteyn took this mosaic concept to the next level, measuring the speed and spectrum of stars across 200 locations. But the real game changer came in 1917 with American astronomer Harlow Shapley. He studied globular clusters and realized something terrifying. The previous maps were wrong because they assumed the sun was the center of the galaxy. Shapley proved we aren't special. We are actually living out in the suburbs, on the edge of the galaxy. Right around the 1920s, the legendary Edwin Hubble looked through his telescope and realized the universe is filled with other galaxies, and they basically come in three shapes. First, you have elliptical galaxies, which look like big, fuzzy, glowing balls. Second, and most common, you have spiral galaxies, beautiful flat pinwheels with a dense core and sweeping arms. Third, you have irregular galaxies, which are just a chaotic mess of stars. This was the ultimate aha moment for astronomers. They looked at that glowing milky band in our sky, the one we see from the desert, and realized it looks exactly like a spiral arm viewed from the side. If our galaxy were a ball, stars would be scattered everywhere evenly. But because we see a flat line, we know we are living in a flat disk. Modern technology brought the final clarity. In 2003, NASA launched the Spitzer Space Telescope. This thing didn't just see light, it saw heat. It used infrared to cut through the thick dust clouds that block our view. Spitzer proved our center is a massive bar of red stars. Later, the Neowise mission mapped it further, showing us that we have two major arms, the Perseus and Scutum Centaurus arms, and a few minor ones. So, we didn't take a snapshot, we built a portrait by meticulously stitching together thousands of tiny observations, data points, and infrared scans over hundreds of years. We finally pieced the puzzle together to reveal the spiral beauty of the Milky Way. Alright, that is it for tonight. If you made it to this point, you are absolutely the best. Do me a huge favor and hit that like button before you head out. It really helps the algorithm and lets us know how many of you stayed till the very end. And hey, if you ever have a burning question that keeps you awake at night, write it in the comments below so we can answer it. Most of the episodes we make right now come directly from your comments. Peace.